Alright, this is just a short little video on how to add and subtract fractions. So things like finding common denominators, that kind of stuff. So if you're having a little trouble with kind of remembering how to add and subtract fractions that you learned in elementary school, use this as a little refresher to kind of get yourself caught up. So we have a couple of steps that we need to do in order to add or subtract fractions. And the big piece is that in order to do it, they need to be broken up into the same size pieces, meaning we need to have a common denominator. So like in our example here, one of them is broken up into ninths, one of them is broken up into sixths. Those are not the same size pieces, so we can't just add or subtract them easily. So the best way to do this is let's jot down these steps, and this is kind of what we do for each one of our problems. So first we need to find a common denominator. We want to change these denominators to the same thing. To do that, we find the LCM, the least common multiple of our denominators. So basically, what could a 6 be turned into? What could a 9 be turned into? What's the first thing that both of those numbers change into? So think of 6, 12, 18, 24, counting up by 6s, counting up by 9s. Once you find that new denominator, you're going to rewrite the fractions using the new denominator. Remember, whatever you do to your denominator, you have to do the same thing to the numerator when you change them. Then you're going to add or subtract the numerator pieces. The denominator always stays the same. So you're not adding or subtracting the denominator. And then, like any good fraction problem, make sure that you simplify when you are done. So let's try this first one together. 4 ninths minus 1 sixth. First thing you have to do is look at these two denominators and try to find a new denominator that works for both of them. Well, a good thing to check is, could I turn the small one into my bigger one? Could I turn a 6 into a 9? Because if I can, then I don't have to do a whole lot of work in rewriting my fractions. Unfortunately, 6s don't turn into 9s, so I have to start to look for some other options. So now start to think of bigger versions of 6 and bigger versions of 9. What could they both change into? If you're not sure, look at your multiplication table. So I have 6, 12, 18. So kind of think of your multiples of 6. Think of your multiples of 9, and look to see where do those numbers match up. You'll notice that very quickly we realize that 18 works for both a 6 and a 9. So I'm going to change my denominator to be an 18. Next part is we're going to rewrite them with the new denominator. Remember the rule, whatever we did to the denominator, we have to do the same thing to the numerator. So I ask myself, what did I do to 9 to make it into that 18? Well, I multiplied times 2. So I'm going to do the same thing up top. 4 times 2 is 8. What did I do to 6 to get to 18? Oh, well, I multiplied times 3. So do the same thing to the top. You should absolutely show that work next to each of those problems. That way you can kind of go back and see what was I trying to do instead of trying to guess at what you were trying to do in the problem. Once you've rewritten them with a common denominator, now you're ready to go ahead and add or subtract. Subtract the numerators. 8 minus 3 is 5, but denominator stays the same, 5/18. Then we check to see if we can simplify. 5, the only thing I can multiply to get 5 is a 1 times 5. 5 doesn't work for 18, so I know that this one is in simplest form. So let's try another one. If you think you've got a handle on it, go ahead and try these two on your own. If you're not quite sure, follow along and kind of work your way through with me. Here we have 1/5 plus 7/10. So again, we want to rewrite our denominators so they're both going to be the same thing. We need to find something that a 5 can turn into and a 10 can turn into. Well, turns out I can turn a 5 into a 10. That way the 10 just stays the way it was. So I can turn a 5 into a 10 by multiplying by 2. So I do the same thing to my numerator. 1 times 2 is 2. This one's already a 10. That's what I want to change it into, so it stays as 7/10. Now I'm ready to add 2/10 plus 7/10. 2 plus 7 is 9/10. And then I check to see if I can simplify. The only thing that goes into 9 are 3's. 3's don't go into 10, so 9/10 is my final answer. Now we try the next one. 5, 6 minus 3/5. Again, we got to figure out what can both a 5 and a 6 be turned into. Well, I can look at my multiplication chart and start writing out my 5s. 5, 10, 15, 20, 25, 30. Same thing with my 6s. 6, 12, 18, 24. And you'll notice that the only time that they match up with each other is at 30. That's the first time that they match up. So if you've got two numbers and you're having trouble finding something that works, consider just multiplying the two numbers together. 6 times 5 is 30. That'll always work for your common denominator. Now we rewrite the rest of the fraction. To get from 6 to 30, I multiply times 5. So I do the same thing to my numerator. I have to change them equally. To get from 5 to 30, I multiply times 6. So I do the same thing to my numerator. 3 times 6 is 18. Now I'm ready to actually do the problem. 25 thirtieths minus 18 thirtieths is 7 thirtieths. And then last step, check to see, can I simplify it all? Well, the only thing that 7 can be divided by is 7. 7 doesn't go into 30, so I lucked out again, and this one doesn't have anything to simplify. So I came out quite nicely. So remember our steps. You're going to find that common denominator. You can try like our first problem. Can you turn your smaller denominator into the bigger one? If not, start counting by each of the numbers. Where are they going to match up? When all else fails, you can just try multiplying your denominators together. That will always give you a denominator that works. Sometimes it's a little big, but sometimes that's your only option.